Welcome everybody, and thank you for joining us for today's webinar presented by AI Media, Live Captioning with IP Video Standards. We would like to ensure that this session is accessible to all. To add captions, you can go to the bottom right of the screen, click More, and then select Show Subtitles. You can also customize how these captions are presented. Just go to the subtitle settings and you can change location, font size, and so on. My name is Alexandra Prince-Sadler, and I am the Global Marketing Executive at AI Media. Our featured speaker for today's webinar is Bill McLaughlin. Bill is the Chief Product Officer at AI Media and the former Chief Technology Officer at EEG. There is a scheduled time at the end of this webinar for all of your questions. Please add them to the Q&A box and we will try our best to get all questions in the scheduled time. Now I'd like to welcome Bill for the Live Captioning with IP Video Standards webinar. Let's get started. Bill, over to you.
Thank you, Alex. Good to be here. I'm presenting from New York today, and really glad to be presenting kind of a special time, a little late for me, but it's no problem for our Australian and APAC audience. You probably know us well as AI Media. AI Media has been in business for almost 20 years and does, a lot of really successful things in Australia and the APAC market, Australia being the home headquarters. We work in, a variety of, really marquee Australian broadcast media and entertainment customers, do a lot of streaming live events for local and multinational companies, and work with a lot of the universities in the region to do both live and recorded subtitles for all of their content. Recently, a year ago, AI Media acquired EEG, which is a United States-based company, and EEG has been in the captioning and subtitling business since the early 1980s, primarily working in the video technology space and making captioning coders, working in IP streaming video, and pioneering the ICAP network, which allows captioners from all around our country and all around the world to actually connect in through a secure mediated network to reach broadcaster encoders and live streaming events, and to make workflows involving human captioners in all kinds of languages, as well as automatic captioning and automatic translation work into all of these different broadcast products, and get those skills and that intelligence into the local video streams in a seamless way. So the new AI Media with EEG really provides a one-stop shop for what you need to do captioning and subtitling, between the technology needs, the cloud needs, human services, multinational, multilingual services, live subtitles, recorded subtitles. We're able to do a lot more than a lot of the traditional smaller and single purpose vendors in this space, and a lot more than either of the companies was able to do independently just a year ago. So it's something, it combines, the EEG heritage with a lot of proprietary technology investment over many years, merging that with what AI Media has done with their own investments in the recorded and services space, and a global multilingual footprint to be able to deliver captions everywhere. So what we're going to talk about in today's webinar, though, is primarily about the Alta series of products. And the Alta series is really the fastest growing in our video enabling technologies. It combines basically the concept that we've been doing caption encoders and inserters in SDI video for many, many years, and brings that into the more modernized production workflow of doing video in the cloud, doing video in virtual machines, doing video essentially in software and by API and over Ethernet, and making all of the things that you used to need a lot of dedicated cables and plant to do broadcasters and event producers are now able to do that less expensively, less fixed investment, able to turn it on and off and make the changes they need to make, and able to monitor it all through software and, run through a more standard, worldwide kind of software workflow. So that's what Alta is all about. And we're going to go in a little more detail into looking at the types of IP video formats that you can put in and out of Alta, the different types of global captioning that are supported, some typical use cases, some typical deployment cases, and some highlights for what we've been working on next, especially since, the release of a big batch of new features at the NAB show in the United States in Las Vegas in April. But even in the 3 months since then, there's a number of new features that a lot of our customers have gotten quite excited about. So when we talk about the Alta product, I spoke about this a little, but where is this landing for our customers? And this is a little bit focused on what broadcasters are seeing in the media and entertainment business, although a lot of it can apply to streaming live events and enterprise video as well. We're seeing a lot of momentum behind an SDI to IP transition, meaning moving away from an on-prem by necessity, very hardware-oriented SDI video plant to running IP video. And IP video can be still in an on-prem plant, although often it gives you an ability to do on-prem video in a way that's more flexible, that's higher density, that's lower power, easier to maintain. It also gives you the flexibility to really start thinking about taking the next step, which is video production almost entirely using cloud-based systems. And once you're in an IP-based system, that's possible because you're using software and networking, and you don't need a bespoke physical infrastructure that isn't going to be available on AWS or any other popular commercial cloud service, right? You're going to need your own on-prem facility when you're using SDI video, when you're using telephone routing lines, when you're using, GPI contact closure. Alta and all of the other products that are in, today's generation of video production help the customer move away from that. In captioning, what's also happening simultaneously with that is that customers are, sending content, this is especially true in sports, more and more globally and needing to localize in more and more regions. We're finding ways with OTT distribution to distribute essentially more and more niche events still at a profit because you can produce the events less expensively. You can actually go out and reach that highly segmented audience online. And it leads to a desire to see how traditional caption workflows can be upended to really alter the trade-offs between being able to do more hours of closed captioning in more languages, but often looking to reduce the cost of the closed captioning per hour. And, that's meeting a new generation of AI technologies in speech to text and in text to text translation that are enabling us to inch closer and closer to the most premium levels of expert human quality using automatic systems. So these things are kind of converging together to the point where really we know all broadcasters at this point have an AI plan, have a cloud plan, and it's really, in your eyes, it's not so much going to be, are we ever going to do this? It's going to be, when is it practical to do this? Is the technology ready now to do the complex things we need to do and to satisfy our audience? And of course, there's a widespread belief, which I would share, that when it's not ready right now, the time is still probably soon, that we're kind of on that edge where more and more becomes possible. Alta sits in that workflow by essentially taking a video in and out in the same way that any other captioning coder would, and connecting to the ICAP cloud for captions. And what ICAP does, it actually doesn't mention on this graphic that there's hosting in Sydney now, but there is. ICAP basically provides a relay service for the captioning that prevents the broadcast facility from needing to deal with inbound connection from the captioner facility, or even from captioners working at home or from any other cloud service. It prevents you from having to deal with that as a specialized IT issue within the video production facility. And so instead of connecting, a specialized, single purpose VPN and dedicated connection to a captioner facility, having the captioners handle all of that IT on their end, with ICAP, it's pretty much plug and play with your unique token to a commercial secure cloud. And you're able to connect through a transparent whitelisted connection to ICAP servers. And when you provide the captioning access token, either into the Lexi service or to AI Media's captions, or even to one of our third-party partners, they're able to use the ICAP network to hear audio and video feedback from that caption encoder with ultra-low latency, and to send captions back across the secure connection to the encoder. And at that point, they're merged into the production path. So they'll come out either in embedded captions in a stream that might be, it might be the US-based 608, 708 format for certain types of streaming applications. In broadcast in Australia or most other English-speaking DVB countries, you'd be using the DVB teletext. For other non-English languages, you may use the DVB subtitles standard. Those are all supported in different flavors of the Alta product. And essentially the workflow diagram is going to be the same. It's also essentially the same for SDI. So if there's a mix plant, a mix of needs, a mix of things that are going to be on the cloud and on-prem, ICAP and Alta support all of that. And it's really easy to group the different encoders into different, into groups that can be addressed with the same captions in a flexible way, depending on the time of day or what type of program it is. Even, complex networks running a mix of regional and local packaging for things like sports, you're actually able to control all of that dynamically and in software through ICAP. So that makes it a lot easier than if you have to have fixed IP addresses or any other type of, fixed non-virtualized routing to get between caption sources and the caption encoding into the video. The basic Alta that we've most been talking about, and probably the simplest concept from SDI, is to talk about the compressed stream workflow. So this will work with an MPEG transport stream, and that MPEG transport stream can be wrapped in the network in a couple of different ways. We support RTP. We support RTP with FEC or forward error correction. We also now support SRT, which we'll talk about a little later as a new feature for extra security and error correction capability over like internet style networks. So what you do is you feed into the Alta stream either a unicast or a multicast that has the compressed video, and we will both add the caption data and can optionally provide a full transport stream multiplex for the outbound signal. So you can actually get a master signal with captioning out of the Alta software, and it would be, IP in and IP out. So it's fully flexible to be virtualized. It can, they can come in and out on the same network, or you can use multiple network interfaces, and that's all. That's all very flexible to a variety of IP workflows. You also are able to use the product in the way some other live caption insertion products can be used in the transport stream domain, you're able to use it with an external multiplexer. So in that case, you would only need to feed ICAP with, really only definitely with audio for the captioner to get an audio feedback. You could also feed it with video, even a reduced resolution video. If the caption positioning can be done without video, you don't even have to feed any video. But essentially what would come out then would be only the DVB elementary stream that has the teletext or subtitles data, and then that can be multiplexed externally based on the PCR timings with the rest of the stream. So that's another really common workflow, and that kind of keeps the subtitling in a side chain from the main video. In SMPTE 2110, which now a lot of broadcasters around the world have been looking at going directly from an SDI to a 2110 workflow, right? Because effectively compressed has become very, very popular for a lot of types of OTT and remote contribution type of workflows. But the issue with the compressed workflow is, you don't have that full HD or UHD resolution. You also don't necessarily have the same, frame by frame editing and triggering capabilities that you have in the baseband SDI workflow. So SMPTE 2110 is an uncompressed video standard over IP. So, it requires a lot of IP. You'll typically need a 10 gigabit per second networking throughout a distribution network. And our Alta 2110 product will take the 2110 audio stream in, which is somewhat lower bandwidth. You'll typically be looking at something like 5 to 10 megabits per second, depending on how many channels. And that will go to the caption sources through ICAP. And what you'll get out is 211040 ancillary captions. So that's basically a stream of VANC packets, typically the OP47 VANC packets carrying live DVB text data. And those packets are stamped with a time synchronized timestamp using the PTP standard as the official time synchronization in 2110. And that synchronized ancillary stream will come out and then can be recombined with the video and the audio stream, essentially in a similar way to the way the transport stream workflow would work when you were using an external multiplexer. And with 2110, everything works that way, right? Because it has a separate video, audio, and ancillary stream. And that's the intention. They're separated. You can operate on them separately, and they're time synchronized, so you can put them back together from any number of sources at any downstream point in the chain. You can caption in a few different formats across these IP video standards too. So, in most of Asia and Australia, you'll be targeting for broadcast the DVB specifications. So that kind of comes in two flavors that set-top boxes and other receivers typically support. And one of them is, based on the older teletext standard, but that's very commonly used for live, especially. It has an advantage that it's essentially very easy to convert into other formats, whether that's for streaming or for recording or other purposes. There is also the DVB subtitles format, and the main advantage of the subtitles format is that the subtitle is fully rendered at the time it's sent in the broadcast plant. So the key advantage of that is it means that you can support character sets that will support any world language, whereas teletext, as well as the North America standard 608 and 708, have much more limited language support. Typically only Latin character languages are used. So the DVB subtitles are much more international. The downside of that, they take up a lot more space in the stream because they're fully rendered. They also are not as easy to repurpose or to send to a stream to, decode in any way other than the way they were originally presented, where they're kind of resolution dependent and all that because they've already been rendered. So that can be the disadvantage. So that's the reason why a lot of times, the teletext standard, for example, is more widely supported in streaming appliances along with the US standard, because it's much easier to take that and repackage that into HLS streams, into time text or VTT caption files that will be delivered live. The subtitles are comparatively fairly hard to work with. Another option that is fairly widely used for a variety of reasons is to put on open captions. And when we say open captions or subtitles, we mean, for example, the way when, a film with foreign language subtitles will appear, where, it's not a on-off decision for individual viewers. They're just on the screen and they're part of the video program itself. So obviously they'll follow the video program wherever that goes. They'll scale with the video program. Has some of the same disadvantages of a DVB subtitle style approach, but then the real advantage is you don't need any type of special decoder to see it. It's just part of the video picture and everyone will get it. All of these captions can also be created by a variety of caption sources. So depending on what the target of an event is, what the budget is, what the topic matter is, and how difficult we think it's going to be for a human captioner to work on it, or for an automatic captioning system to kind of hear the speakers well. We offer a number of options. AI Media's Lexi and Smart Lexi options are ASR powered captioning. They provide quite good accuracy in a lot of common program types. It's even usable for broadcasting, for program types that are relatively straightforward, news programming and things like that. It supports a lot of languages, and it has a lot of customization features, including a Smart Lexi package we offer, where customization and a lot of other scheduling and monitoring and a custom audit is provided to the customer as part of their caption packages. So Lexi really offers a very simple API-driven pay-as-you-go SaaS model that's pretty much self-service, or we have the Smart Lexi model, which is more similar to the service level that traditional broadcasters would receive from human-based captioning. We also remain the largest supplier, certainly in Australia, of the human-driven captioning, and we have a great roster of expert voice captioners and stenographers. That can be really especially helpful if you feel that there's, difficult topic matter that the training the model for Lexi is going to be too difficult or time consuming, not someone that something has for. The human captioners also are very well trained to kind of handle all the unexpected things that can come up, either during live events or during, a complex broadcast schedule, where automating some of those things is tempting, but can actually be more difficult than really having an expert on hand to handle it. And that kind of guarantee of having your own expert working the job still is one of the keys to why premium human captioning is so widely used, despite all the ASR alternatives that are in the market. Alta does support human captioning primarily through ICAP as kind of our best, most virtualizable protocol. We also support legacy protocols like TCP/IP or Telnet connection, which will allow a captioner to just make a point-to-point connection to a single encoder. One of the benefits of that is that it would allow a captioner who was on site along with the encoder to, remove any need to connect out to the cloud or out of the building. You could just connect locally to the encoder, and you wouldn't have a need necessarily to hear the audio and see the video through iCap, because the captioner may be on site, they may have access to a monitor in the studio, they may be in the same room with the presenters or the forum. So there might not be a need for that more complex transaction. We also have ability to do various styles of captioning that might involve a pre-prepared file or a hybrid between pre-prepared scripted material, whether that's from a news script, pre-recorded caption files, etc., and to be able to merge that with live human captioning or Lexi. So, one of the things that I think is really interesting about the iCap approach is that it creates a situation where you have the same technology footprint in the broadcasting or video production facility, regardless of what kind of source of captioning you're going to use. And therefore, it doesn't have to be difficult to do something, like on a one-off basis when there's a special need to use either a more human-based approach or a more automated approach, depending on what kind of unusual things come up. It's really all built in there, and you just have to, obviously we need some notice a lot of times to actually get the workforce involved, but you have an easy ability to do both of these models. So we'll talk through now some of the newest features of Alta, and this has been a pretty exciting subject recently. Alta is definitely one of our fastest growing products, and the tech everywhere in IP video is evolving very quickly right now. So we have a lot of customers moving over. One of the things that we saw the most momentum on in the past year is customers who are doing streaming, either in a transport stream or some applications through RTMP, and looking to move to SRT transport. So the SRT protocol is a protocol that is basically similar to MPEG transport streams, but it's designed to address the common problems that you can see pushing those streams a long distance or over lossy networks, like over public internet especially. So it compensates for packet loss and delay. It also provides an encryption layer that's quite a bit better supported than some of the other formats that have been used in transport streams before. And support for this has grown a lot in the last couple of years from vendors in the streaming and event space. And we've just released support directly in Alta this summer. So it's now possible to put SRT streams both in and out of the Alta product. It has all of the same features that it would have with a basic transport stream, and is just able to communicate directly with senders and receivers natively in SRT. Whereas, prior to having this feature built into the product, we would have customers that needed to take an SRT stream and put it through a product like, Amazon's Media Connect to essentially de-encapsulate the SRT layer and go down to a plain transport stream. But at this point, that's now a level of extra, setup and expense that isn't actually necessary. Another new feature this summer has been the addition of CCmatch to Alta, and CCmatch is a feature that we've been supporting in our SDI encoders for quite some time. What it's able to do is actually, when it's acceptable to delay your video by a few seconds, it has an internal buffer that will store the video and will line the video up with the live captions. And the reason that's so advantageous is if you look at sources of live captioning, whether they're human or automatic, it's going to be typical to see at least 3 or 4 seconds of delay between a spoken word and the captions coming in. And some of that is technology, the captions being transported from place to place in systems. But a lot of that is pretty inherent to the fact that to know what's said and to translate into text, you need to see not just one full word, but usually several. You usually need to have essentially a coherent phrase for any captioner or for ASR systems to actually know reliably what was said. And that creates this delay, and it's the delay that you don't see when you look at the more perfectly synchronized subtitles that you would expect from, a movie theater or from a program on TV that was, pre-recorded and subtitled in advance. So with CCmatch and Alta, we can actually remove that live subtitle delay and produce much better timed live subtitles. It will improve the user experience a lot for the subtitles. It also helps around problems with clipping off of captions at the end of segments. If you think about it, if the captions are always 5 seconds delayed, the implication will be that if you have a commercial break or any other kind of segment or change, and there's less than 5 seconds of silence or music or filler as an outro, then some of the captions may not appear on the stream until after the video source is already switched to a different commercial or clip. So that actually will cause total loss of some of these captions and is kind of a complex problem if it needs to be solved in post-production while doing clipping. It's better if you don't have it to begin with. So we have seen in a lot of environments where the delay isn't highly sensitive, the best approach is to eliminate that caption delay right at the source. We've also worked to put more Lexi automation into Alta, particularly involving the ability to trigger through simple GPI-like signals. So Lexi's cloud captioning already has had for a long time its own HTTP API, where you can make calls to the server directly, giving your encoder's access token, giving your account credentials, and requesting automatic captions, down to the encoder with your selected language and vocabulary model and positioning and other details like that. But on our SDI products, another common way to do that was to just do it with GPI on-off switches. And the GPI on-off switch would, be a physical copper wire, connected into the back of the SDI encoder. Since Alta is a fully virtualized software product, we don't have that kind of wiring. And what we've done is add drivers for a virtual GPI protocol that will allow, a simple message that's really just a on-off that relies on all of the built-in settings, inside the Alta or the SDI encoder, and the virtual GPI can just trigger something simple like, either Lexi on, Lexi off, or it can be gated with some other conditions, such as, on whenever there's, not upstream captioning from a recording or a commercial. So that is a really good way to connect Alta to more traditional broadcast automation systems that still use a GPI-based approach. You can use a converter box from brand like Cooper or DNF. It's also possible to create these messages very simply in any kind of scripting framework or IP-based trigger functions. So another application that's been widely used for is in SCSI triggering. So the SCSI 35 and SCSI 104 standards are being very widely used to trigger segmentation and digital ad insertion in more complex downstream paths where, for example, imagine a content provider is originating an event, and during commercial breaks, there's specific slots that are designated to be sold as local or downstream advertisements, right? And how would an automated system know when to slot in those commercial breaks and how much time it has for the commercial breaks? That's all done through these SCUDdy triggers, typically in MPEG transport systems. So we support insertion of those messages in Alta through both a TCP/IP interface that connects to automation systems, or now through these virtual GPIs. And the virtual GPIs give you an ability to send, very simple messages that are written in presets from Alta, and to just send them in a very snappy time way, and not have to really worry about authoring the entire message, which automation systems typically already do. But in a lot of applications, we find event producers are really looking just for a, kind of a one-touch button panel, rather than kind of creating software that has like a, a more detailed schedule of all the SCUDdy events. You may just be looking to say, okay, each time we have, a timeout or a speaker break, we're just going to hit the button panel and we're going to send the SCUDdy trigger, and we'll send another one when we're returning to air. So that kind of workflow is now supported through Alta through this virtual GPI interface. One more application that we've been working on for a long time, and that we've had more vendors on all the time, is looking at how Alta can integrate with other IP video systems, what will often be called like an integrated playout or channel in a box style system. And a lot of these systems, it's common that they have in addition to automation and graphics and all kinds of stuff, there's a certain amount of captioning support for both live and pre-recorded captions. But frequently there's not really a great solution for problem spaces in how do you connect to a remote captioner effectively? How do you work with multiple caption agencies? How do you get ASR captions in? How do you do multilingual captions? So we see Alta used in these work cases a lot as an add-on to something like an eVerts Overture or ORT or a Grass Valley system. And essentially all you need to do is feed IP audio in a supported standard into the Alta system, and the Alta system will send out the live captions either in a caption command format over Telnet directly into the video playout channel, or in something like 211040 or one of the elementary stream standards for captioning that effectively creates just a narrow stream of just the subtitle data, and we'll send that back in to the general playout system where it can be time integrated, and right from there it's likely to be feeding a number of different sources. So Alta will author the captions once, and that's going to allow them to appear, in SDI, in production IP video, in proxy video, in things that might be going directly out to a third-party streaming provider. So that's often a very efficient workflow. There's still a lot of value in all the things that the Alta product offers. So that's why we make sure to work well with these systems. We've spoken about Alta being a fully virtualized product, but so what does that really mean? It means that we're able to ship the Alta feature set, basically as a VM file, and the customer is able to choose their own hosting for it that's appropriate. So one Alta VM acts as a controller, and that controller can have multiple sub channels in it, where each channel would reflect the ability to put in, one video and audio stream, and to caption it in either one or multiple languages. And you can have multiple channels resident on that same VM. And all you have to do is back the VM with an adequate amount of, CPU cores, RAM, and networking to support the amount of channels that you want to run. And that will work. We support a few out of the box virtualization partners, VMware, Microsoft Hyper-V, and Amazon Web Services. You can also use other stacks and other public clouds by just converting the official images that are provided, using pretty commonly available tools. So when you have these virtualized templates, all you really need to do is set it up in your system, and you can back up your configuration. You can run redundant copies of these with our floating license scheme. It's a very convenient way to set up a pretty redundant, high quality professional system very quickly. And if you're familiar with these systems, it's pretty fast to set up a demo too, and just get something running in kind of a sandbox environment. We do also support like a turnkey full warranted solution that can ship on a couple of different server sizes that we'll actually do physical shipment on, if you're working in a more on-prem environment or looking to build kind of a go rack for events that has physical gear that kind of just cables up in a couple of spots and is ready to go as it's moved from place to place. But all of that's possible with IP video, and we're dedicated to kind of making sure that customers are able to take advantage of that. So, I hope that's been helpful to kind of shed light on what's going on with our Alta product, how it fits into IP video trends going on very generally, and what's happening in the broader caption services landscape too. I think for our ideal customers, they see the big picture and how this is all related. How essentially the goal is to be moving towards a software-driven workflow that means you can control the video over an API, like for example NMOS in the 2110 space. You can control the captioning largely through an API. We're starting to work with a lot of customers on web-based automatable booking, even when they're working with human captioning. So, it's about turning this into a much more seamless software process, which is going to allow more media to go out to the customer, with ultimately fewer errors and a lower cost per hour produced, because captioning is just one of the many costs, of course, that we're trying to compress as we go to more and more events, to more and more screens, still keeping within what's going to be essentially a finite budget. So a lot of great stuff happening there. We're going to make sure that we leave some time for Q&A and questions about Alta, anything you've seen in the webinar, or really any other AI media or EEG products are great. I think I'll be joined back by Alex and also by Josh Huddle, who's my colleague, who's the product manager for our live video insertion solutions. Yeah, thank you very much for staying around.
Thank you, Bill. So as you've just heard, we've now reached the live Q&A portion of today's webinar. Joining Bill is Josh Huddle, one of AI Media's product managers. We have a lot of great questions and we will try to get through as many as possible. Any questions that we can't answer today, and if we run out of time, we will be sure to email you after the webinar. So the first question I have here, what do you suggest for an on-premise solution?
Yeah, so for an on-premise solution, we would suggest our Lexi local product together with an Alta VM. This way the subtitle data can go through your own private cloud and doesn't need to connect to our public cloud server. It supports a bit less languages than the cloud version of Lexi, but it does provide a high level of security and has less network requirements. So that would be our suggestion, most likely.
Great. And our next question that has come through, how many different network ports does Alta need to use in the 2110 environment?
Yeah, well, one interface should probably be enough for running all Alta functions, including the web management, outbound connections to ICAP and Lexi, sending and receiving the media. But for increased bandwidth for each of these functions, you may want to use one interface for each of them. And with 2110 specifically, you can use the S2022-7 standard, which allows for dual networks for complete media redundancy. So this way, if something goes wrong with the primary stream, the second one can act as a backup. So in this case, if you use a standard, you would want to use one interface for each of the media streams in this case. So.
Yeah, it's interesting. Like, right, there's a couple of different reasons you might want to go with the different networks, and for a sandbox setup, yeah, it's not super high bandwidth if you're unless you're running like UHD transport streams. You can easily run it through a single interface, but you may have different requirements in terms of the outbound network. Maybe that's going into a separate DMZ, and that's going to be separate from the media network. If you're having redundant streams or merging streams from different networks. So we support a lot of flexibility on that. Yeah.
Okay, our next question here came through by someone when they registered for this webinar. I would be curious to know more about ICAP Alta running on an on-premise VM, particularly what in and out latency is achievable and how it compares to a typical hardware encoder.
Yeah, so for an on-premise VM, you have various options for VM controllers, such as like VirtualBox, Cisco, Microsoft controllers, and then you can import our Alta over file on it to get started. And then in terms of CPU and memory, we usually recommend setting up one core CPU and 1 MB of RAM for each Alta channel. But yeah, in regards to latency, the hardware encoders typically have about 2.5 microseconds of latency. With an Alta VM, it will be a bit more, but that typically varies depending on the caption output format and the type of video standard that you're using. For example, if you're using Alta in an MPEG transport stream with the ATSC 708 format, in that case, you would expect about a 1 to 2 second delay as a result of the GOP processing that comes with this format for the handling of picture reordering. But if using DVB teletext or bitmap or the SMPTE 2110 standard, this GOP processing doesn't have to occur. So in that case, you can use our low latency option, which would be more like on the millisecond level. But it could also depend on the UDP buffer size that you put for the stream, since the higher the buffer size, the more resistance you'll have to output problems, but the higher the latency and the lower the buffer size, the lower the latency, but the more prone you might be to output issues in that case. So it really varies depending on these factors for Alta.
Yeah, I mean, as with anything with streaming video, you're going to look at like what's the compression standard that's being used and what's the possible arrival jitter on the streams, and that's going to kind of determine how small of a buffer it's possible to run the system with. SDI or a 2110 system has got to be super deterministic, but when you're running in a compressed workflow, you typically less so.
We've had a couple of questions come through now about the cost model for Alta. Is it licensed per server or is it a subscription-based cost model?
Yeah, so it's licensed on a per channel basis. And then, depending on the number of channels that you purchase, you can have one license key that gives you access to all of these channels on one or multiple servers. So, but yeah, it's a per channel basis.
Our next question here, what language does the system support? What languages does the system support, sorry?
Yeah. So we support over 120 languages as a source of captions, using like ICAP Translate and with human captioners, or 30 languages using our Lexi automated captioning. For the output, we can support all Latin characters through all modes, but there are some languages using image-based characters not supported in CEA 708 or teletext, but they can be supported using DVB bitmap in our Alta transport stream product. So yeah, that's basically what our language support is.
Great. So that's all we have time for today, unless you've got any more questions that have come through on your end there, Josh.
Oh, yeah, we got. Yep. These two just came in.
Oh, yep. Okay. I can see those now. Thanks, Josh. Some captioning organizations are responsible for confidence monitoring of the captions, requiring not just audio monitoring, but also video monitoring. Is low latency and low bitrate video monitoring on the Alta development timeline?
Yeah, I mean, it's whether video is being routed to the Alta systems is kind of a decision that's being made at the input level. So on the transport stream products, it usually is, although not always. If it's being like if it's kind of a replacement for a product that's using the external mux, then sometimes, right, if you're using the internal mux to start with, you need to put in the video because you're producing a new master video from Alta. And so then the captioner is going to get video feedback. If you are using an external mux, it's no longer, a requirement in the program path, but it still might be a good idea because it does provide that video feedback. And the video feedback is going to be helpful for the live captioner to actually be able to read graphics on the screen, to be able to kind of they may be able to dynamically adjust the caption positioning to some extent. It's also something that can provide context even with Lexi. Like we have a Lexi vision feature that actually uses automatic image recognition to move the captions around based on the position of graphics and text that's detected on the screen. Of course, to make use of that, you got to feed the video through ICAP. So it's usually a good idea. It's not commonly done yet in the 2110 product, only because the bandwidth of the video really kind of changes the density a lot that you're able to run through the product. So the video bandwidth is about 1,000 times the audio bandwidth. So it's kind of a game changer. But I think that that's something like, especially with the development of some of the standards like 2110.22, which allows compressed video over a 2110 network, that's probably going to get realistic in more places soon, and as the 10 gig networking ports honestly become probably less expensive and less exotic over time as well.
Great. I think we have touched on this one, but I'll read this out again. Is there a subscription pricing model for Alta, like there is for Falcon? We'd like to run Alta in AWS.
Yeah, so yeah, that is similar to the other question, but basically, no, there's no subscription model for Alta. It's a per channel basis. So yeah, unlike Falcon, it's not like a monthly or subscription or anything like that.
Okay, great. We've got a couple of minutes left. I'll just check in with you again, Josh, and see if there's any that have come through on your end there.
Oh, yep, here we go.
Yep, thank you. Any plans to support NDI as a transport?
Yeah, that's a good one. Yes, we're planning to do that. Interestingly, the NDI standard doesn't really have a fully standardized support for closed captions that's compatible with all vendors, but actually we have been discussing with with some other partners an ability to kind of tunnel that data through more generalized metadata specs on NDI, and it's going to work. I think I've heard this works through the Grass Valley NDI system, which is becoming pretty widely used. So we're actually are expecting on our roadmap to produce a system on that pretty soon. It's kind of going to be interesting, I think, to see like how many productions are moving towards a NDI for the places where captioning is typically done, right? Because captioning is usually kind of a final step after some of the things that NDI is really great for, being able to do like a software vision mixer and things like that, where you have different contributions and different sources, and they can be different resolutions and not full screen. And captioning is really going to typically happen when you have your kind of fully assembled final video and audio program. And but if that's still pumping through NDI, and as long as we have a receiver that's going to be able to take the captions from that and either pop them into open captions or be able to put them into other useful formats like a DVB format or an embedded captions format, ultimately in a transport stream, then I think it's a great application.
Okay, we've got 3 minutes left, so we'll sneak one last question in there. Can the way the text for caption is displayed on the screen be formatted at the server and or client level? I'm watching this live stream on my Chrome browser, and the captions on both the CC box and the transcript is only showing one line at a time. Any response to that one?
That's
a limitation on the Zoom webinar for sure. And yeah, agreed. The Zoom webinars do not have the easiest to read captioning. It really depends on the system what kind of caption formatting options are available. Like broadcast TV, right, will have a certain set of options with people's cable boxes. Different video players will, some of them have a lot of selectability with the font size and the font color and have all that in the user's hand, which is great. Other systems like just do it one way. You sometimes see streaming players with what I call the dreaded sprawl out, where essentially the captions like start in the middle and grow outwards in both directions as each line grows. So there are worse things than Zoom, let's say, but Zoom doesn't offer a lot of configurability. We certainly have some clients who work with our AI Live system as an alternative to using the captions directly in Zoom. AI Live would provide you with a separate link for your web page or device that displays the captions, and it's out of the Zoom direct ecosystem, but does provide you then with like a really robust set of options, like what font do you want, how much history do you want, what speed do you want. So I think that's kind of honestly why there's always room for some of the solutions that care a little bit more about the caption quality. And maybe we should have had an AI Live session for this webinar.
Thanks, Bill, and thanks, Josh. That's all we have time for today. There are a couple of questions that we didn't get to. We will answer those questions and make them available to attendees. We will also be sending a recording of this webinar and a customer survey to all registered attendees. We look forward to hearing your feedback. I'd like to thank you all for attending today. We've had a great turnout for this event. And to Bill and Josh, thank you for your time and expertise that you've shared about live captioning with IP video standards. And a special thanks to the live captioning team behind the scenes that have made sure this event is accessible. If you have any other questions about AI media and EEG or any other topics that we haven't discussed today, you are welcome to reach out to us. Thank you all again, and we hope to see you at the next webinar.
Thank you. Good night. Good afternoon.
Thank you.